Hello class, welcome to our lesson for today. Again, we are still in our revision winding down on what we've been learning all through. So now let's see what we're going to learn today. For today's aspect, we are still going to have some revision questions. But this time, we'll talk about the revision questions still in terms of the type of questions we get to be asked, covering different topics. Now we know what we've covered so far in our online learning. We have talked about magnetism, measurements 2, moment of a force, equilibrium and center of gravity, curve mirrors, waves 1, sound, fluid flow, and Hooke's law. The only from two topics we will cover is magnetic effect of electric current. Hopefully we will next time. So we still have those 5 types of or categories of questions that you find in any physics exam or CAT, any kind of test. We have the statement questions, where you have to give your answer as it is, factual, as it is, preferably in the KB textbooks. You set laws, you set rules, you set principles, or give factual answers like factors and all that. We have the descriptive questions, where to, in pro form, explain how something happens step by step. And we say that it helps if you have a diagram in that. We have the comparative questions, where you have to show the difference between one thing and the other. This is like this, why, that is like that. We use words like why, but, whereas. Sometimes you can even use a table showing what is on one side and what is on the other side. We have numerical questions or the mathematical type of questions in physics, where you have to list what you've been given, identify the formula to use, and go ahead and work it out. Then we have the graphical questions, where you draw a graph with x-axis, y-axis, or you sketch one, independent variable on the y-axis, the vertical one, the dependent variable on the x-axis, the horizontal one. But of course, also depends on the rules that will be given, what should be where. So that is that. Let's start with the statement question. Now again here, for today, I'll have 3 questions covering different topics, but they are all statement questions. The first two is to state laws. State the law of magnetism. Second one, state the law of electrostatics. The reason why I chose these two is because some students normally confuse in giving the answers to this. Law of magnetism. We have talked about a magnet in depth, and one thing that is very obvious about magnets is that they have poles. North-seeking pole, what we call the North Pole, south-seeking pole, what we call the South Pole. We did look at the properties of magnets, the directional property, how a freely suspended magnet will always come to rest in the north-south kind of direction, and what we call the polar properties, that magnets have a north pole and a south pole. Now that is the basis of the law of magnetism. You know what happens in attraction? The like poles do repel, and like poles do attract. We demonstrated this in our lesson, and that's the basis of the law of magnetism, that like poles repel, while unlike poles attract, the North Pole and the South Pole. If you bring 2 similar poles, they'll be repulsion. We demonstrated that practically. If you bring 2 unlike poles together, there'll be attraction. So like poles repel, and like poles attract. When we come to electrostatics, here we talk about objects that are charged, positively or negatively. We did say that there are some which are neutral, depending on the number of negative charges and positive charges in them. So the statement for electrostatics is that like charges repel, while unlike charges attract. If you bring 2 objects close to each other, and the objects are both positively charged or are both negatively charged, they will repel just like magnets repel because of similar charges, not similar poles, similar charges. If you bring two objects close to each other and they happen to be having opposite charges, positive and negative, bring them close to each other, they will attract the same way magnets attract when they have different poles, but this one will attract because they have different charges. So the law is that like charges repel while unlike charges attract. Simple facts, straight to the point, the way it is in the textbook. Now statement questions may also mean not just giving a law or a principle or a rule, but can also be about giving facts, giving the condition, giving the factor, and so forth. For example, give the factors affecting the speed of sound in air. Give the factors affecting the speed of sound in air. Now, sound is a wave, transmission or disturbance through a medium. In this case, the medium is air. Sound is transmitted because of vibration of molecules or particles. Now, to transmit sound, like from me to you, the listener, there has to be that vibration from, of course, the voice box comes out, is transmitted through air because of vibration of molecules by compressions and rarefactions. But the speed of sound in air is affected by several factors, including wind. Is wind supporting the flow of sound or blowing against it? That will either increase or reduce the speed of sound respectively. Wind is one factor. Secondly, density. Density of the air. Is the air so dense or not so dense? Because dense air will mean there are so many particles close together, while if not dense air means particles are far apart. Of course, air moves faster when the molecules are closer, or sound moves faster when the molecules of air are closer to each other than not. What about, density may also affect what we call humidity. Humidity means molecules of water are closely packed with molecules of air. That can transmit sound faster. So that's another factor that affects speed of sound. So we talk about wind, density, humidity, and then also, very important, temperature. Like during the day, because it's very hot, sun is shining, sun rays come to the earth, the radiation, and it's reflected back, okay, because of the type of surface on the earth. It warms up the air above the surface of the earth and the air goes up. That affects transmission of sound because the molecules are far apart. At night, the reverse happens because it's cooler around the surface of the earth, molecules are closer together. That's that. So sound is affected, the speed of sound is affected by all those factors: wind, temperature, humidity, density. You give them as facts. You either number them in Roman numbers or in small letters, but don't use bullets and dots to give your points. Just list them. Okay? So that's statement question. What about descriptive questions? Where you have to give your answer as a paragraph, and if possible, draw a diagram. It makes it easier to understand, to express yourself, and use as few words as possible. Let's look at this descriptive question to help us answer that. How will you determine the thickness of a sheet of paper? How will you determine the thickness of a sheet of paper? Now I have with me here a book. This book, okay, it has a thick cover on that side, a thick cover on this side. But what I mean is, how do I determine the thickness of this sheet of paper? Because the sheets of paper here are all the same, of the same thickness. This one, the cover is a bit thicker to protect what is inside. Now, normally what you do is, to get the thickness of one sheet of paper, you put a known number of papers. Let's say 200. or 300, or 400, or 500, like a ring of foolscaps, okay, or even more. When you get this thickness, this bunch of paper, so many of them, let's say you know that they are 500. Then what you do, using a suitable tool, you measure the thickness of all of them. Okay, you get the thickness. Let's say it is 5 centimeters. So 5 centimeters for 500 sheets of paper. So how much is a sheet of paper? 5 centimeters divided by 500. 0.01. That is centimeter. That's how big a sheet is. 0.1 of a millimeter. Now that brings us to the end of this first part. We have talked about statement questions and descriptive questions. So in descriptive question, give your answer as a paragraph. If possible, mathematical formula at the end and a diagram as well. So we continue with more of the type of questions and how to answer them in our second part. So we'll talk about statement question, descriptive questions. Next will be comparative questions, numerical questions, and then graphical questions. See you in the second part.